A little intro about me. I'm a full stack software developer. I'm Adelen Festin, and I've been developing Ruby on Rails and Elixir Phoenix applications from start to finish for Deal Grocer, Beauty MNL, and ShopLife. So for the past 2 to 3 years, all our applications have been on Ruby on Rails. And the journey was great. Everyone was happy. Developer productivity was high with the English-like syntax and also the ease of deployment with AWS. We were able to develop a lot of applications. But then, as most businesses, the business needed to scale, which means we had more traffic, and of course, we had to increase the number of available servers. Increasing the number of available servers is something that developers must also think of because that also means cost. So eventually, we had to manage a lot, and it is not only increasing the number of additional servers that one must worry about, but also preventing single points of failure. So also, the current CPUs in the market today no longer becomes dramatically faster than previous years. Now, what we have are machines with multiple cores, which is great news for us because it means that our code could run faster, but only if it could run concurrently, meaning different bits of code running simultaneously in the different cores. So during that time, Elixir was also picking up speed, and it is very well heard in the Ruby community. Because in addition to the almost similar constructs to Ruby, it also provides the power of Erlang. Because Elixir uses immutable data structures, which helps prevent issues that is common when using programming languages that are object-oriented. Also, in addition to that, the creator of Elixir is, which is Jose Lim, is a core Ruby on Rails contributor. So the learnings, the experiences with Ruby on Rails were kind of like transferred to Elixir. Also, the core team members of Elixir were previous main contributors of Ruby and Ruby on Rails. All right, so tonight, let me give a brief introduction to Elixir by covering the 3 main points. So number 1, that's functional programming, pattern matching, and OTP and concurrency. Also, as added features, we'll also be looking into web development with Elixir and documentation. This will be exciting. All right. So first, functional. Functional languages offer a different paradigm, which is different from what object-oriented and imperative languages give. For example, as I mentioned a while ago, it uses immutable data structures. I think functional programming is quite familiar to all of us. For example, when we issue commands in our command line using the pipe operator. So here, we know that we are piping the results of PS-EF to the grep operator. So with Elixir, it has the same construct. So for example here, what we do is given this array, we first make it as an input to this function, and then we expect that this function provides an output, which is then will be an input to our third function. What you can see here also is that Elixir makes us think in terms of steps, in terms of data transformation, that our data or our processes need to undergo to achieve a specific output. It could be compared as to how we write in other programming languages that, for example, it will consist of nested parentheses, which is not that readable because we need to find the innermost parentheses to know where it all started. So this is one of the cool and also useful syntactic structure of Elixir, the ability to pipe. Also, to give us a basic feel of how Elixir looks like, as you can see, it's very English-like. The basic data structures are here. You have your integer, your floats, You also have your strings. We also have string interpolation. Is it clear? Can it be seen? Okay. So we also have list. So very normal, very ordinary, also readable. Now you might ask, okay, so how do we have objects? How do we represent objects, meaning entities that have the same attributes, that have the same structures, behavior? So with that, with Elixir, we have structs. So it is defined like this, and to make one user struct is also just easy, as simple as providing the values for each of the attributes. So this takes into account the attributes. But how about behaviors? So with that, oops, all right. So yeah, I'll show it later. So with that, for Elixir, we have protocols. They are similar to abstract classes, in which the individual structs will be the one to implement the specific protocols. Alright. So now we proceed to our second bullet, pattern matching, which is indeed a powerful part of Elixir. Okay, let's see the slide. So here we can see x equals 5. All right, no error, we get 5. Next, we have 5 equals x. Still no error, we get a 5. If we query for the value of x, we still get a 5. And then here we reassign x with 1, we get a 1. And then finally, we try 5 equals x. But then we get an error. No match of right-hand side value 1. So in Elixir, actually the equals operator is an assignment. It is sort of an assertion that the right-hand side is equal to the left-hand side. So what it does is, for example, it checks, is x equal to 5? If it is not equal to 5, then it finds a way, if possible, to assign the value of the right-hand side to the left-hand side. So that's why here 5 equals x. What happened is there was no error because x indeed matched the left-hand side, which is 5. So here it expects 1 equals x. So this pattern matching also works for a list. So for example, you have a list 1, 2, 3. So when you pattern match 1, 2, 3 equals list, yes, they're equal, so there's no error. And then for the third one, we put the first element of our list as the variable 1. So 1, 2, 3 equals list. But what happens is the number 1 is assigned to our variable 1. Okay. So another example for list, it's also possible for Elixir to split a list into its head and to its tail. So this is very useful in loops because you're able to pattern match if your list is already empty. So let's take a look. So for example, you separate the head and the tail, so assigning the head part to the variable head and the tail to the tail variable. So you get a head of 1, and the tail are the remaining elements in an array. There. So here we have assigned it to tail, and then we try to do it again, split the array. So we have a head here and a tail equals the previous tail. So we get a head of 2 and a tail of 3, 4, 5. Okay. So another use of pattern matching is for error catching. It is useful, for example, for parameters. You're expecting certain keys to be visible, to be present in the input. There you can catch that, oops, this certain key doesn't exist. For example, we were sent the parameters name, earth, gravity 9.8. So what we can do with pattern matching is assign the value of the name key, so to planet, and the gravity to g, params. So what we can get is planet, earth, g 9.8. And then let's do another hash with the missing parameter of gravity. So missing params equals name, Mars. And then when we try to pattern match name planet gravity G equals to the hash with only the name key set, what we get is an error. So this is very useful, especially for functions where we need to check that the input must be complete. All right. And then one last slide for pattern matching. Pattern matching is also useful in function definitions. So for example, in Elixir, we can have multiple function definitions, and each of them could have different bodies depending on the type of the input. So for example, we want to make a Fibonacci application. So first, it checks if the input is a 0, it returns a 0. If it is a 1, it returns a 1. Else, if it doesn't fall in any of the previous conditions, it goes to the base case. There. So probably in other programming languages, we would write this as using switch statements, case. So there. So at least here, it's quite clear that what a specific function does depending on the input. Also, I think with this, we are able to think already of the base cases of what are expected of our functions. And then finally, for our third bullet on OTP and concurrency, so Elixir's main motto is fail early and fail fast. Being built on top of Erlang, it is able to utilize OTP, or the Open Telecom Platform, which is used by a lot of telecommunication companies in providing power to the telecommunication industry. So all right, so OTP provides applications with fault tolerance. So that's why it's fail early and fail fast, because there is assumption that the system will be able to recover and be up and running in a sane state. So how does Elixir does this? So number one, we have supervisors. So when building your application, you are able to build a supervisor tree where you can define hierarchies such that a supervisor will look over a child process. And then you can define specific strategies wherein do you want this specific supervisor to restart the child in case it fails? Or do you want that the whole system will restart when one child fails? Also, supervisors are there to compartmentalize the failure and restart the system in a sane state. So here we just have one level where there's one supervisor and one child, but we can also have a tree of supervisors. Another one for concurrency is message passing. So it's very easy with Elixir channels to pass messages between processes. So here we can see that this function, schedule adds fetch, sends the message get adds to itself after 60,000 milliseconds. So that's like 1 minute. And then when it is called here. So it's like sending a process to yourself. In a way, it is also timed. All right, and then lastly, for the last 2 bullet points, we have web development and documentation. So for web development, we actually have Phoenix. It is very similar to Ruby on Rails. It's also an MVC framework. And if you're familiar with Ruby on Rails or Python Django, very similar. So it also yields high developer productivity and also high application performance. Here is a sample code snippet of a controller with Phoenix. So here we are able to use the pattern matching that we saw earlier. So it assumes and expects that the parameters include the username and the password keys. All right. So that's for web development. Any questions so far?